you are required to use the trapezium rule to estimate the value of the area bounded by the function below with 5 ordinates. All right. So you're going from 0 to 1. All right. Now, you have a certain formula. That's called the trapezium rule. But let's discuss a bit about the trapezium rule before we work it out. Remember, we're not in exam today. We want to look at reasoning behind the working out of the math. All right? So we take our time to do so. Remember, if you have a trapezium, let's say, let me see now, this is H1 and call this H2 and call the width. Should I use X? Alright. We could call the width X, since the width would be along the X axis. Here, the area of the trapezium. If you say area is equal to H1 times X, you would be talking about this area here, which would be too small, because you would have left this part out. Alright? If you say the area is H2 times X, it would be too large because you're looking at H2 here, and you'd have added something right here. So it's too large. So you make a compromise. These would be out. So you say the area equals the average of H1 and H2. So H1 plus H2 over 2 times X. Alright. You can call this half X H1 plus H2. Remember that. Area of a trapezium. Now, if there's a case where you have a curve, and say you have this trapezium, and you have H1, H2, you have another trapezium H3, so you have another trapezium H4, alright? So this would be 1, 2, 3 ordinates. Let's say we have 4 ordinates. H5. Alright? Alright. So let us find the total area. Right? The area is equal to, let's say, A1, A2, A3, A4. So we have that. Oh. All right. So here now, the area of 1. Remember, all of these are X, the same width. All right. X1, X2, X3, X4. All right. So what we have is X throughout, same X, is half X for the first one. So H1 plus H2 plus half X for the second. All the X's are the same, so I'll just call them X. So we have H2 plus H3 plus half X for the third. And then you have H3 plus H4 plus half X for the fourth one. Remember, we have all these areas 1, 2, 3, 4. Oh, why did I do this? Let me just erase the extra line. It fooled me a while ago. the entire thing erased. I just want the edge to erase. Yeah, that's all we're doing, finding this area. Right. Alright, so this is H5, the height. Alright, good. So all of these are the heights. Let me just label them for clarity. All of these are heights of the trapeziums. So we have half x h4 plus h5. And if we should factor out the half, so area would be half, and factor out x, inside we have h1 plus h2 plus h2 plus h3, which is this, plus h3 plus h4 plus h4 plus h5, which is there. You see that? We're just looking at how the thing there, the trapezium rule is formed before we do that. So it's half times the width x times what happens in the bracket. You have 1 h here, the front, or the first one. There's 1 h1, there's 1 h5 plus h5. Alright, let's not do that. Plus h2 plus h2 is 2h2 plus h3 plus h3. That's 2h3 plus h4 plus h4. That's 2h4 plus h5. Now there are 2 h2, which that means 2 of this, 2 of this, 2 of this. 2h2, 2h3, 2h4. But there's only 1h1 and 1h5. So here, what we can say is the area is equal to half times the width times the first height, right? So the height, the first height, plus, let's put this one in front, plus the last height, plus 2 times the other heights. All right? So first plus last plus twice others. We could rewrite this with less writing and say h is equal to half w, or half x. Maybe I should have used w in the first place. First plus last plus 2 times the others, and that is the trapezium rule, right? All right. Now let's look at this. The integral from 0 to 1 of x e to the x dx. So we have the integral from 0 to 1 of x e to the x dx. Alright? We're supposed to use 5 ordinates. This is 5 ordinates. Now x e to the x dx. How would that look? I think maybe it looks something like this. Alright, however it looks. Alright, so that's 1, 2, 3, 4, 5. You have 1, 2, 3, 4, 5 ordinates. Alright, we have x in the formula, so let's just use W for the width. All of these are the same W, same width, 5 of them. We have H1, H2, H3, H4, H5, H6. Alright. Sometime you might start at H0. Right? H0, H1, H2, H3, H4, H5. But we start at H1, so we just work with it. Now, here, what are the values? H1 is at 0. Oh, guess what? This will be 0. The first one will be 0. So let's just redo the diagram. We would start at 0. And in fact, let's use some straight lines as well. Right? The first one would surely be 0. So we have this 1, 2, 3, 4, 5. It's kind of narrow. 5. Alright. Alright, so here 0 and it ends at 1, but they say 5 ordinates. So 1/5. What is 1/5 of 1? 0.2, and then 0.4, 0.6, 0.8, 1.0. So here we have H1, which will be 0, H2, H3, H4, H5, H6. Now here we look and see that we're going to need the heights. Let's find the heights first. Right? Now, what is H1? H1 is equal to, that's when x is equal to 0. H1 at x equals 0. H1 equal 0 e to the 0. Right? 0 times e to the 0 is 0 times 1, which is 0. H2 is at x equals 0.2. So H2 is equal to 0.2 e to the 0.2. Alright, let's get our calculator. Alright. So we have 0.2 times e to the power of 0.2 equals, we get 2.443, 2.443. All right. H3 is at x equal 0.6, no, 0.4. H3 is at x equals 0.4. So H3 is equal to 0.4 e to the 0.4, which is what? Just get our calculator. 0.4 multiplied by e to the power of 0.4 equal. We have 0.5967. All right. So 0.5967. H4 is at x equals 0.6. So H4 equals 0.6 e to the 0.6 equals. So what is that? Let's clear our calculator. 0.6 multiplied by e to the power of 0. I want 0.6 equals 1.0933, 1.0933, 1.0933, right? Oh, to make things line up, let's put this, line up this with the others. Alright, and line up this with the other ones. Alright, good. All the equals form a neat line. Alright, so here now, what is h5 is that x equals 0.8. So h5 equals 0.8 e to the 0.8 equals, so we get our calculator. We say 0.8 multiplied by e to the power of 0.8 equals, what we have is 1.7804. Alright, 1.7804. And then 86 is at x equal 1.0. So what is 86? 86 is equal to 1 times e to the 1. E to the 1 is e. 1 by e is e. So it is e. E is what? 2.718. I remember that e is 2.718. You can get it by saying e to the power of 1 equals. So you get 2.718. We're using 4 decimal places already, so let's be consistent. Alright. Well, we could write the 0 as 0.000. 0. We had 2.443 here. Alright, let's just put everything to 4 decimal places. The 0.2 e to the 0.2 was what again? The 0.2, I realize that that's to 3 decimal places, everything else is to 4, so let's be consistent with it. 0.2 multi, my gosh, I missed that. 0.2, it's clear. 0.2 multiplied by e to the power of 0.2 equal 2. Hold on. Oh, that's a mistake. I wrote 2.443 something. It was 0.2443. My. Alright. So it's 0 point. This should have been 0 point. Right. So that's that. Alright, so the trapezium rule. Each width is 0.2. Alright. So the trapezium rule says half the width. So the area equals half the width. Half times 0.2 times, alright, the first plus the last, the first height plus the last height. So the first height is going to be 0. 0 plus the last height is 2.7183. 2.7183 plus, let me write this bracket as a square bracket because we're going to have a round bracket in there. It looks neater when I do that. Plus 2 times, no, it's going to be 2 times the others. 2.44. Oh boy, I tell you, you know, time 0.2443 plus 0.5967 plus, and you see it takes long to work it out, you know, because you're doing it by hand, step by step, using the trapezium rule instead of direct integration. Direct integration will be quick, much quicker, I mean, would give us the answer long time ago. Anyway, let's continue. 1.0933 plus 1.7804. Okay, wow. So we have that. All right. So the area is half of 0.2 is 0.1 times. All right. So it's going to be 2.7183 plus 2 times. All right, we have all of these things to add up now. So let's get our calculator and add them up. We have 0.2443 plus, all right, 0.5967 plus 1.0933 plus 1.7804 equals, we have 3.7147. All right, 3.7147 that we have here. 3.7147. Okay. So the area equals 0.1 times 2.7183 plus, then we want 3 times this. So if we take this and say that times 3, you get equal 11.1441. All right, 11.1441, which is 0.1 times, then we add it and we say 11.1441 plus 2.7183, plus 2.7183 equals, we have 13 point, so we have 13.86 something another. All right. Oh, hold on, what's going on? I had 2 by 3 something, so how it come to 11? No, hold on. Let's go back to this. Like I make some mistake here. We had the 3.7 something. 2.3. Let's work it out. So we had 2 times. Oh, I'd multiply it by 3 instead of 2, you know. My. Oh boy. It's 2 times 3.7147. 2 times 3.7147 equal. It's 7.4294 it should be. 7.4294. My. So this should be 7.42. 7.4214 it should have been. And then 294, not 14. 94 it should have been. Right. And then I say that plus 2.7183 equal. All right, I have 10.1477, 10.1477. All right, and then when you multiply this by 0.1, you get 1.0147. Let's write it to 3 decimal places. 1.015 it would be, right? If you write it to 2 decimal places, it would, writing it to 3 significant figures would be 1.02. All right? So that's what we have. So I recommend you practice this. Try it again. Particularly if you didn't get it when you tried it earlier. Try it again and work it out without looking back at any notes. Alright? See you in the next video.